Everyone, and I welcome you all to today's video. Today we are going to look at some of the distance metrics for similarity and normalization of data points. We are going to understand these concepts by solving certain question of first internal test, part B, similarity and dissimilarity in feedback. My name is Manas Pathak and I am a student of IIPS DAVV. So let's start. In the previous video too, we looked at some of the distance metrics. Today we are going to see an additional distance metric which is cosine similarity and the normalization of the data points. So the question for today is, consider student faculty similarity analysis, a sample data set of two attributes, faculty responsiveness, infrastructural support, given a new feedback query, x is equals to 1.4, 1.6. A, rank existing students feedback profiles by similarity using Euclidean, Manhattan, Supremum and Cosine similarity. B, normalize each student vectors to unit length and recompute using Euclidean distance. So in the first part of the question, we have to calculate the Euclidean Manhattan cosine and supremum similarity for each of the given data points with the given data point, which is 1.4, 1.6, and in the part B we have to normalize each given data point and also the data point x, which is 1.4, 1.6, and then again we calculate the Euclidean distance. So let's first find the different type of distance metrics which are given to us in the question. First, the Euclidean distance. The formula for Euclidean distance is square root of sum of squared differences between the sum of squared differences of data of the values corresponding values of two data points. So here we'll calculate that by taking the values of each data point in x and taking the values for given data point in y. After the calculation, we get the following values. Now, for Euclidean distance, smaller the distance, greater the similarity between two data points. Hence, S1 is the most similar to the given data point, and S2 is the least similar to the given data point, and S4, S3, S5 lie in the middle. Moving to the Manhattan distance, the formula for Manhattan distance is sum of absolute differences between corresponding values of two data points. Now again, taking the values for data points in x and taking the values of given data values for given data point in y, we'll calculate the absolute differences and add them. Therefore we get the following values after performing calculation. Again, for Manhattan distance, smaller the distance between 2 points, greater their similarity is. Hence, ranking based on similarity would be S1 being the most similar, then S4, S3, S5 and S2 being the least similar. This is same to the Euclidean distance ranking. Now moving on to the supremum distance. The formula for supremum distance is maximum of the absolute differences between corresponding values of two data points. Hence, we'll calculate the absolute difference between each of the values in two data points between the given data point and the data points which are already available with us. And then we'll find the maximum of the absolute difference between the two, and that difference would be our supremum distance for each data point. So hence, after performing the absolute difference calculation and finding the maximum, we get the following results. And then again, ranking based on similarity would be the smaller the distance, greater the similarity. Hence, S1 is the most similar data point, while S3 and S4 are equally similar to the equally less similar than S1 to the given data point, and S2 and S5 are equally least similar to the given data point. Now, cosine similarity. For cosine similarity, it considers the two data points between which we have to find the similarity as two different vectors, and then if it considers them as two vectors and finds the cosine of the angle theta between these two vectors. The formula for it is a dot b divided by a magnitude into b magnitude. A dot b here refers to the dot product of the two vectors. Hence, this is the formula for the cosine similarity. Now substituting the values for data points in x and for the given data point in y, we get the following values. Now for cosine similarity, closer the value is to 1, greater the similarity between two data points, and closer it is to 0, the less two data points are similar. Hence the ranking based on similarity would be S1, S3, S4, S2 and S5, where S1 is the most similar and S5 is the least similar. Now coming to the normalization of data points to unit vectors. Now normalization, the unit vector normalization, in unit vector normalization we divide the values in each data point to the corresponding magnitude of the data point. So the here in the formula, the for s dash is equals to s comma under root of s1 square plus s2 square. Here the denominator, which is under root of s1 square plus s2 square, corresponds to the magnitude of the data point, where s1 and s2 are respective data values in the data point, and s here is the each corresponds to the each value in data point. So each value in the data point would be divided by its corresponding magnitude to find its unit vector normalization equivalent. This is similar to the conversion of a vector to the unit vector, which you must have studied in classes 11th and 12th. So now performing the calculations based on this formula, we get the new data points as this. So now basically what normalization does is it scales the given data values to a particular range. So, and with that range is normally between 0 and 1. So as you can see, all the data points here are between 0 and 1. We have also normalized the given data point x to the value 0.659 and 0.753 by performing the normalization for using this formula. Now the formula for Euclidean distance would be 0.659 minus s1 dash square plus 0.753 minus s2 dash square. Here s1 and s2 refer to the normalized data values for each data point, and 0.659 and 0.753 are the normalized value for the given data point. Therefore, performing the calculations, we get the following values. Now again, as I have already told you, for Euclidean distance, smaller the distance, greater the similarity. Hence ranking would be S1 being the most similar, then S3, S4, S2, and then S5 being the least similar. Now key takeaway from here is that once we have performed the unit vector normalization of the data points, the results of cosine similarity and Euclidean distance would be same. Hence you can verify this from here that for cosine similarity and for unit vector for Euclidean distance on unit vector normalized data points, they have same results. Each one say that S1 is the most similar while S5 is the least similar. So this was all about today's video. I hope you learned something from here. If yes, then please consider liking this video and subscribing to my channel. I'll be coming up with more such exciting topics. I'll see you in next video. Thank you.